Next, let's discuss about the Poisson distribution. This Poisson distribution is denoted by a letter P and a single value parameter lambda. We write the statement below as variable y follows a Poisson distribution with lambda equal 4, and here we can see this distribution y follows the parameter lambda. While talking about the Poisson distribution, this distribution deals with the frequency with which event occurs in a specific interval, which means the Poisson distribution requires knowing how often an event occurs in a specific period of time or distance or area. Suppose we are counting number of occurrences of an event in a given unit of time or distance or area or volume. For example, we might be counting the number of car accidents in a day. Then the number of events is going to be the random variable that may or may not have the Poisson distribution, but it depends depending on the specific of the situations. But a Poisson distribution, Poisson random variable is a count of number of occurrences of an event, defining the variable in terms of time. Suppose if we are defining the variable in terms of time, this Poisson distribution is the probability. It's a probability distribution that can be used to show how many times an event is likely to occur within a specific or specified period of time. In other words, it is a count distribution. These Poisson distributions are often used to understand an independent event that occur at a constant rate within a given interval of time. As mentioned earlier, the independent events, which means events are occurring randomly and independently. In other words, knowing when one event happens gives absolutely no information about when another event occur. So if this condition holds, then the random variable x, which represents the number of events in a fixed unit of time, has the Poisson distribution, and or this Poisson distribution can be used to know how many times an event is likely to occur within the x number of time. And Poisson distribution can be used to estimate how likely is that something will happen x number of times. So we can describe in this way as well. Now what we will use to calculate the probability is that random variable x takes on the value little x, as in our previous distribution, which we write sometimes the p of x is equal to the lambda power x times e power minus lambda and which is divided by the x factorial. Here the e represents the mathematical constant, the base of the natural logarithm, and its value is approximately 2.71 and 28. And so this probability mass function that we use to calculate the probabilities for any value of x, that is 0, 1 to infinity, and lambda is the expected value of the x given this lambda value. And suppose, as we mentioned earlier, this Poisson distribution is used to estimate the how likely is it that something will happen x number of times. So we have a simple example here. Suppose if the average number of people who rent the movies on the Friday night at a store location is 40, then a the Poisson distribution can answer such questions as what is the probability that more than 60 people will rent the movie, or we can see that we can see the distribution of the Poisson of this Poisson with the observations ranging from 0 to 80. So with when this average number of the people who rent the movies on Friday story is given as the 40, or here our lambda value is 40. So basically it's about the Poisson distribution, which is basically this Poisson distribution which is used to estimate the how likely is that something will happen some x number of times.